True or Die Tuesday, the 9th of March. You guys will be able to use and understand trig functions for right triangles, finishing 7, 4, and 5. All right, we talked about SOHCAHTOA. SOHCAHTOA. Who can tell me what the SO stood for? Bill.
It's sine.
Sine.
Of.
Nope.
Is.
Sine is.
Opposite.
Nope. Opposite. Yes, I
Over.
opposite over. Hypotenuse.
I got 2.
What was ka? Aiden.
Cosine is adjacent of the hypotenuse.
Very good. What was toa? Bill, you get a redemption shot here.
Tangent is opposite over adjacent.
Tangent.
I didn't read
I don't know why I wrote this one out. Is opposite over adjacent. Very good.
I redeemed myself.
Okay. So those were our 3 trig functions we learned. Sine, cosine, tangent. And we had SOHCAHTOA to help us remember these. They're ratios. Then we found sine, cosine, tangent of angle B. Then we found sine, cosine, and tangent of angle A. We noted the relationships between these. Aiden, what is your question?
What's the story behind that tie?
Behind this tie? I got it as a birthday present from a guy that I share a birthday with.
No, you have to give us.
All right. No, not right now. All right. Rules for using trig ratios. We went through these. We didn't finish, did we?
No.
Okay, I got to the very end, I believe. Okay, actually, I think we just finished this section, but I'm going to recap this section. So when we were finding x here, we said we can find that with just one side of the right triangle and one other angle of this right triangle. Now, the only other time before we learned at 7.2 that with one side and one angle, we could find the other sides of the right triangle was with a 30, 60, 90 or a 45, 45, 90. This is neither. This is a 35 degree, 55 degree, 90 degree triangle. Not special at all, okay? Not everyone's special. Just kidding. Not every triangle is special. Max.
I thought we had to know 2 of the angles.
We do.
We do normally. But here, do you technically know the other angle?
Yes.
But you're just given one. So you know one non-right angle. So you know one angle other than the 90 degree angle.
Yeah. Okay, so what's that 76, basically?
Yeah. Yep. Fair question. All right. So here we're saying based upon this angle, 35 degrees, we know this is the adjacent side, this is the opposite side, and this was the hypotenuse we said. Now we are given the hypotenuse, we are looking for the opposite, so we say, okay, for SOHCAHTOA, which one involves O and H, that would be so. So we said sine. So we set up the ratio of sine of the angle, sine of 35 degrees, is equal to the opposite x over the hypotenuse, 14. And we said, okay, well, how do we get x by itself? Well, we multiply both sides by 14, or 14 over 1. And we end up getting 14 times the sine of 35 degrees is equal to x. What we don't do is take 14 times 35. Because we are doing the sine of 35 degrees. That is an operation. Just like multiplying is an operation, sine is an operation. We have to do that sine before we can multiply. From here, we can do a couple things. You can type it in your calculator, or if you have an Apple calculator, an iOS version, you have to do a little more work to it as well before you get there, because it's not a true scientific calculator, unfortunately, okay? Android calculators or my TI-30s over there, 32? Anyway, are scientific calculators that are good and trustworthy as well, or a TI-84, okay? Or Calc-84, okay?
It's degrees, right? Not radians.
Yes, and you need to be in degrees, not radians. We talked about it last time. If you're having trouble on a test or on a homework, by the way, and you need to switch from degrees to radians, you can ask me, and I can help you with that. Okay? Does that make sense? Okay. Now, we could do it a couple different ways. We could say 14 times the sine of 35, put that in your calculator, and you would get approximately 8.03 to be our x. Now, we could also say you would put in you would just put this in your calculator.
I did that. I got like 490.
Yes, because you have an iPhone calculator, right?
9.5479.
Gage, you have an iPhone?
Yeah, I do.
Okay. Yep.
I got Android.
Sign, but yes.
Oh.
Yep.
5, 9,
Yep.
10, 14.
Yep. And now if you want to, guys, Gage, go back one step and do the sine of 35. So just do 35 and hit sine.
And then do times 14.
No, don't even hit times 14 yet. And tell me what you get to 4 decimal places.
I got negative something.
You are the worst.
No, literally, look, 35.
You're in
Fine.
radians right now. Let's go to degrees. There you go. Try it again.
Oh, 35. Fine. There we
Okay,
go.
so Gage got to 4 decimal places,
0.57.
0.5736 if we round it. Now, is that exactly that number? No, it went on forever. But we're going to go to 4 decimal places when I'm asking you these, okay? So if you were to approximate out sine, cosine, or tangent ever, I want you to go to how many decimal places?
4.
4. It's going to be a little more accurate than going 1 or 2, okay? The farther out you go, the more accurate you're going to be. I've noticed, though, the reason I say 4 is when you go 4 versus 3 or 2 or 1 on this, it's really about as accurate as we need it to be in here, okay, for our purposes right now. Other classes, other scenarios, it might be necessary to go farther, okay? But right here, 4 is accurate enough for us right now, okay? And if you were to multiply 14 times this number, 0.5736, and just the 0.5736, can somebody tell me what you get? So somebody would need to do that in their calculator. 14 times 0.5736.
8.0304.
8.03. So did we get the same thing?
No.
Yeah. We got the same thing whether we rounded it to 4 decimal places or we typed in the actual sine of 35 degrees. So that's why I do 4 decimal places, because as we round earlier on the next one, it ends up helping that one be more accurate. Aiden.
What is the math behind sine?
Sine is the ratio. So sine, the math behind it is saying, hey, if this angle is 35 degrees in a right triangle, the ratio between these two sides has to be exactly that. So if we were to find this side length to be 8.03 and this side length to be whatever it is, this side length to be 8.03 and this side length to be 14, the opposite and the hypotenuse, and you were to divide the opposite by the hypotenuse, you would get approximately 0.5736. So sine is the ratio between those two side lengths. Does that make sense?
Not really, but
Okay. So here, whatever your ratio between two sides in a right triangle are is going to change based upon what our angle measure is. So as this angle gets bigger, this side's going to get bigger. As this angle gets smaller, this side's going to get smaller, right? Now, so as that changes, the ratio between the opposite and the hypotenuse is going to change with it. Now, for every single right triangle out there, the sine of 35 degrees will always be this ratio. So if you were to take the opposite divided by the hypotenuse, whatever those lengths are, you would always get that. But continuing on, you would always get that, simplifying it down. Every time, as long as this was 35 degrees. If it was a different number, you get a different number.
oh, I see. Okay.
Does that make more sense?
Yeah, I see what.
Okay. Now we could use it with other ratios as well, so we could figure out the adjacent by using cosine, because it'd be adjacent and hypotenuse, and we go through the same thing. I want to talk about something here with angle of elevation and angle of depression. This is not in your notes.
Oh, that is me. Angle depression.
Okay, yes. Okay, now this is going to be a perfectly horizontal line. I know it doesn't look like a perfectly horizontal line. Pretend with me that this is a perfectly horizontal line, okay? Are we in pretend world with me?
So much pretend.
Okay, perfect. Perfect horizontal line from point A. If I am looking straight ahead, and then I say, okay, an angle going down from there would be an angle of depression. Depression is related to being low, okay? Well, normally when we've heard of depression, you've probably heard of the mental or emotional state of depression, or someone being depressed, okay? And that is a low emotion. Okay, on the spectrum, it's a low emotion. A high emotion would be positivity, energy. Depression, a lower emotion, would be related to more sadness and lack of energy. Okay? So, or if something is depressed, it is lowered. Okay? Now, if something is elevated, it's going up. So they're opposites of each other in this. So if I say from here, 1 second, Saren, and I'm looking down, compared to my straightforward horizontal, that would be an angle of depression. Compared to my straightforward horizontal, going up would be an angle of elevation. Now, if you don't have a perfectly horizontal reference point, you can't say whether something or not is elevating or depressing. Okay? You can't say if something's an angle of elevation or an angle of depression unless it comes specifically from a horizontal view. So looking straight ahead would be a horizontal view. So from here I can say going up would be an angle of elevation, going down would be an angle of depression. If I'm just looking down at my feet though right now, I can't say if I go down farther, it's an angle of depression. I can't say if I go up a bit, it's an angle of elevation. It has to be from that horizontal. Saren, what was your question?
This is like for the emotion thing. What would it for anger be? Because anger.
It would be straight down.
I'm not sure exactly where anger can be classified in the emotion. It'd probably be kind of one of the. It'd probably be considered a high emotion because it's still dealt with more energy.
Yeah, it would raise your because it'd be the elevation because it's elevating your blood pressure.
Angle.
But
Elevates until you
So
get
it's
down.
angle of angle and angle of depression, right?
What I think is
angle of elevation and angle of depression.
Just
What do you
put
meaning
that
angle
L
of
thing.
angle?
Just put the L thing.
Angle of
El
angle.
Macho.
Angle
Oh,
of
anger.
Angle of LF.
So I heard angle.
Rage.
All right, we need to know that because we're going to be using that here in a moment.
Oh, no.
A rope staked 20 feet from the base of a building goes to the roof and forms an angle of 58 degrees with the ground. To the nearest tenth of a foot, how long is the rope?
About 20 feet.
Now, in word problems, I tell my students all the time to underline key information.
Numbers.
The other thing I do, especially for geometry, I don't do this as much in algebra 1, but for geometry, what would be the other helpful thing?
Draw a picture.
Draw a picture.
And
yes,
label.
thank you, ladies. Draw a picture. Underline pictures. Underline pictures. Underline pictures. What's some things we can underline here? Bill, are you answering that or do you have a question?
I want to answer.
Okay. Yes.
I want to answer like all.
Okay, the whole problem?
Yes.
Okay, well, let's do a piece at a time here. Who can tell me some key information? Okay, Aiden.
20 feet.
Okay, it's stake 20 feet from what?
Base.
From the base of the building. Okay, Jacob.
An angle of 58 degrees with the ground.
Okay, it's an angle of 58 degrees with the ground. That's important. Okay, Bill.
I'm waiting to answer.
Okay, you're going to be waiting a while, buddy. You might want to put your hand down.
I got this. I want.
Okay, okay.
An hour and a half.
Okay, alrighty. Anyone else want to tell me some key information?
How long is the
Okay, how long is the rope?
Yeah.
In what measure?
The
Feet.
nearest tenth of a foot.
Nearest tenth of a foot. Okay. What, Saren?
Oh, I was just raising my hand because I wanted to beat him with raising his hand.
Oh, you can't even.
Oh, okay.
I'll go on
Um,
class again.
Alrighty.
Dude,
I'll set a timer.
Picture. Who can help me with a picture? What can I do for my picture here? Kaya, what are you thinking?
Draw a straight vertical line up and down, and then after that, go horizontal from the bottom of that line, and then draw a hypotenuse. And since it's the vertical line with the building,
Yep.
the horizontal with the ground, so we're gonna assume that's 90 degrees, right? Can we do that?
Yep. Horizontal to vertical, we can. These are the windows on the building, and that's the door.
Is there a triangle on the building?
That's 90 degrees, and we know
That is a weird building.
Oh, guys. Kaya's telling me stuff here.
And we know that the rope is staked 20 feet from the building.
Okay.
So the horizontal line is going to be 20 feet.
Very good, very good.
And then
And this is the rope over here.
it says that from the base, yeah, okay. Then it goes to the roof and forms a 50 degree. Okay, so the hypotenuse and the horizontal line, that angle between that's 50 feet.
Very good. Kaya is exactly correct with all of that. And Kaya, you did a very good job of describing that and explaining that. Kudos to you. Slap on the back, okay? You earned that. Now, here, an angle of 58 degrees with the ground. Some of us might want to put it up here, but is that an angle with the ground?
No.
No. Okay. Now, and it goes up. So what kind of angle is this 58 degrees?
A cube.
An angle of
Latitude.
elevation or depression?
Elevation.
Elevation is going up from a horizontal. The ground's horizontal. It's going up from the horizontal, okay? So we have a 58 degree angle of elevation, it can be said as well. Questions on the setup?
And the rope is X.
And the rope is our X we're trying to find. Very good, very good. All right.
I chose the.
Bill, how would we set this one up? Ooh, I love it.
I'm waiting to answer.
Okay, Aiden, what are we going to use here?
Since we only know the adjacent and the hypotenuse, we're going to do cosine.
Very good. We know the adjacent for the angle we're given is 58 degrees, and we're looking for the hypotenuse, so we want to use cosine. So the cosine of what? 58 degrees. We always take sine, cosine, or tangent of an angle. Cosine is equal to blank over blank.
Starting to doubt myself.
Sorry, 20 over x. Very good. Adjacent over hypotenuse.
Oh,
Now here,
this.
we have to try and get x by itself again. So this is algebra now. How do I get x by itself? Kelly.
I'm sorry. How did you get cosine?
Yes, very good. We got cosine because we said based upon our angle we have here, what do we have and what are we looking for? We have the adjacent. We are looking for the hypotenuse. And according to SOHCAHTOA, we want to know which of these three, sine, cosine, tangent, involves both the adjacent and the hypotenuse, so we choose cosine. Yep, that was probably a question a few of us had. Who else had that question? Okay, a few of us, okay? So if you have a question, don't be afraid to answer or ask it because a lot of times other people want to know that question as well, okay? So that's how we chose cosine. That's going to be a big part of these is knowing which one to choose, okay? So now, how do we solve for x in this equation? Saren.
This is how to solve x in that
He's
equation.
going against me.
Okay, Aiden.
Divide each side by 20.
Not divide by each side because here's what happens if we were to divide each side by 20.
Divide
Okay.
each side by 1.
So if we divide each side by 20,
1.
or multiply by a 1 over 20, which would do the same thing, that reduces that. But now we have cosine of 58 degrees
Like new test.
divided by 20 is equal to 1 over x.
Which is just x.
And so it's not just x. Is 1 divided by 5 the same thing as 5? No. So x is not the same thing as 1 divided by x, unless it's 1.
And there's possibility.
Very slim.
It doesn't say like one.
So, do we want x to be in the denominator? No. So here's what we're going to do. We're going to multiply by x over 1. Because what's going to happen? Is there going to be an x in the denominator on the right-hand side anymore? No, they're going to reduce, and what are you left with on the right-hand side? 20. Now, what do I do? What do I have to do if I multiply the right side by x? Multiply the left side by x. So I'm going to have x times the cosine of 58 degrees is equal to 20. Now what would I do?
I have no idea.
What is divide by cosine of 58 degrees? Because it's multiplying with x. We're going to treat cosine of 58 degrees as if it's any number.
Equals 1 equals 5, 2, 9, 9, 1.
And we add to both sides. And so we get x is equal to 20 divided by the cosine of 58 degrees. So now we type that in our calculator and let it do the rest of the work for us. Once again, scientific calculators are our best friend right now. Okay? And Bill, since you've been waiting so patiently, what do we get as our final answer?
I think I'm wrong.
Oh, awkward. Okay, who can help me on what they think is the length of this rope to the nearest tenth of a foot?
I can help.
Do you want to? Okay, I'll give you. You've been patient. I'll be patient for a moment.
He's just like shit.
Don't talk. Okay, 37.74.
Okay, so the nearest tenth of a foot,
Yeah. Oh,
37.7
37.7.
feet. I would agree. Did anybody not get that in their calculator right now?
I got it, but it still raised my head.
I did
Okay.
that.
Okay, I mean you can put your hand down since I'm calling you, right?
No, I have to beat Simon. I'm a very
Okay.
competitive person.
Hi, very competitive person, Mr. Carlson. Nice to meet you.
Forgot how to do it.
Okay, so for this one, on an iPhone calculator, first of all, you just get a scientific calculator to make your life easier, or you download Calc 84. If you were to do this on an iPhone calculator, you'd have to type in first 58 cosine. Then you would write that number to 4 decimal places there. You'd write it down. That'd make your life easier. And then you take 20 divided by that number. Because the thing is, you have to remember it somehow. And so taking 20 divided by that would help you.
There's a much simpler way on iPhone calculator.
What did you do on the iPhone calculator?
You put 20,
Siri.
the 58 cosine.
Did it work for you?
It does work. 37.
I'm surprised that worked. Because
You just gotta say,
yeah, seriously, guys. Calc 84 is better than the iPhone calculator. The iPhone calculator is not good. I'm saying this as a person who owns an iPhone. The iPhone calculator is trash.
Hey, is yours the same case?
No. But straight up, the iPhone calculator is trash.
I'm not including
Get a scientific calculator. Get a graphic calculator. Get Calc 84. You will save yourself so much headache. My goodness. It is worth it. Okay, Aiden, are you stretching?
No.
Okay, Aiden.
What is grad? G, Gradient.
Yes. So that's some sort of radiance. I don't know what is specific. It's some sort of radian variant that calculator is defaulting to for some reason that we had to change last time. All right. Yes, Kelly. It'll have a few.
Math.
Maybe. We'll do one homework later that's just going to be literally just going to be story problems.
Are you serious?
Pretty cool. All right. Any other questions on this before we move on to example 3? Okay.
Oh, my fingers are losing blood.
Example 3. A pilot is looking at an airport from her plane. The angle of depression is 29 degrees. If the plane is at an altitude of 10,000 feet, approximately how far is it from the airport?
A lot.
Okay.
Mucho far.
First steps on the story problem are going to be what, guys?
Try.
Draw and underline the information. What's the information we need to underline here?
Angle of depression is 29.
Angle of depression is 29 degrees.
Altitude of 10,000.
Altitude of 10,000 feet.
How far is it from the airport?
How far is it? And it's approximate.
And pilot.
Okay, do we need to know it's a pilot? Not really. Do we even know it's a her? No. Do we need to know it's on a plane? Technically, no.
Actually, it is a boat.
What kind of plane is it?
Okay. Yeah, you don't need to know that either. Okay. Who can help me with my picture?
I got you.
Gage.
Okay. So you draw the straight line up. Straight line up.
Okay.
And that is 10,000 feet. Right?
Okay.
Yeah.
If you say so.
And then you draw
Draw the
you
plane.
draw a run over from the top, right?
Draw a tower.
From the top.
I draw what from the
A
top?
line from the top. Make a triangle. But like less far than that.
Put your arm in a
Draw like
Yeah, like
triangle.
that. Sort of.
Put your arm in a 45
And then like
degree.
make a triangle.
45 degrees.
No.
Make a triangle.
What is
Okay,
this?
I'm so confused.
No, he's got it right. Just flip it around. Actually,
Yeah.
no, it doesn't matter. Yeah, he's got it.
And then like the 29
Just trust
is
me.
the
He's
angle
looking down
on the
at the
far
airport.
side.
Yeah, looking down.
That side.
Yeah, he's in depression. Just deal with it.
So is this where the pilot is?
Yes.
Yeah.
Oh, that's a really steep angle.
I don't like this.
What? No.
Oh my gosh.
What is
No.
that?
That's the airplane.
He nailed it.
That's actually not bad.
Aeroplane.
That's not that bad.
That's not that bad.
My armpit hurts.
When I started drawing it, y'all were like way more upset at me than when I finished. Just saying, it's not that bad. It's like what?
It looks like a mummy
It
fellow.
looks like a Santa sloth.
So?
His eyes are cross-eyed.
Yes.
Why is one wing longer than the other?
I don't know. Why is one of your legs longer than the other?
It's not.
Are you sure?
Why can you walk on one of your legs and you can't walk on the other?
Oh, that's so close.
Okay. All right. So, Gage, you're saying that this angle then here is going to be the 29 degrees?
Yeah.
Okay.
I hate this picture. I really do. It's hurting my head.
What's wrong with
It's
it?
Stop. No.
Triangle.
Stop. You made it all.
Triangle.
No.
You guys
Stop.
have an
No.
issue?
The
Mr.
pilot
Castle.
is looking down at the airport.
Yeah, the airport's down there.
Where?
What?
At the
No.
bottom.
Okay. No. Stop. Stop. No.
Perfectly fine. This is what the
No.
Yes.
Yes.
No.
No.
Delete all of it.
Stop.
Kelly.
No.
For reference, just to try it out, can I try to draw another picture?
Oh.
Can I have you draw
Oh.
another
Make
picture?
them.
Yes.
Thank you.
Alright.
No.
We'll do it over to the right.
Do a vertical.
We'll see which one's better.
Do a vertical line.
Okay.
And
Like over on the far right or the far left or the middle?
All that.
No, other side.
Just like middle.
Where like the words start, where they created. Do you know he's actually
Like there?
1,433.5 away.
And then draw the hypotenuse.
It's a lot harder than
Which direction? From where?
To my right.
Which is
From
more
where?
than-
From top to the bottom.
That's too steep.
Alright, and then the 29 degrees is in the top corner because it's an angle of depression that's going down.
That? Nope.
And then
I disagree. Why is this not an angle? Sorry. Why is this not an angle of depression?
Because it needs to be horizontal.
Because not in reference to a horizontal.
What?
Who sucked them?
Gage was right.
It was right.
Yeah.
Because I was also sucked.
Let me show you my picture that I would draw. Okay.
Is mine technically?
I actually drew one like on my paper that like I actually think is pretty good, by the way. Okay, but I'll try replicating on here. We'll see if it works.
Just take a picture of it and then draw a circle around it.
So
All you need to know is Gage was right.
let's say
I'll pull my arm down. You
But
can
it
put your arm
doesn't
down.
look
we have like the tower here. Okay, so that's like the tower for the airplane, like the traffic control thing. Okay, so that's where the airport is. Okay, so and then we have the airplane.
Max, watch siren. What? Watch siren. No. Okay.
Okay. That airplane is about looking really not as good.
I know.
Oh,
This is half. If then that's with
No.
Okay,
The
so
first one's better.
No, I like the second one better.
No.
Yeah.
The second one looks like a bubble letter 4.
Actually, no, never mind. I like Gage's way better now all of a sudden.
Oh.
Yeah,
Wait.
Gage's is better.
I like gauges.
It looks
Gage
like,
isn't confusing.
Yeah,
Merc also
that's
steals
a
it.
square. We're actually dealing with triangles here, not squares.
oh my bad.
I've been.
What's the big pipe?
Yeah. See, mine's the right way. It's just opposite yours.
Yeah, Merc also just take the fan.
That's a lot of zeros.
I mean that's what's accurate.
It's a pretty good plane though. Not gonna lie.
No, the first one's better.
How do we know when to use ghost, tan, and that stuff?
In this case, it is.
Air traffic control tower's not the tall.
How would you know?
Oh, because I've seen one.
Maybe you saw a short one.
I've been in an airport.
Maybe we're in a short airport.
Oh. Ha, if you
Airport's
stand size.
clinically short.
If
You
stand
ever think
size.
about that?
Oh yeah, we did.
Will, you're
Oh,
tall
it's tall as
as
you.
I'm taller than Sarah.
I'm almost as tall as you.
I didn't know.
Almost as tall, keyword. I'm
Yeah.
almost as tall as Gage.
That's not true.
I'm almost None of you were almost tall.
Yeah.
This is the picture I would draw. You have an airplane looking at the airport straight across, but they look down at an angle of depression of 29 degrees, okay? Now, the airport is farther away. The airplane, is 10,000 feet from the ground, hence it being over here. But I just mirrored it over here as well, so you can actually see where the airplane's going.
So
That's what I did.
technically right.
Yes. I would do it similarly to yours, but add more details.
Oh.
Yes, Aiden.
We're trying to find the hypotenuse.
We're trying to figure out how far it is
Hypotenuse.
from the airport.
Well, like how? Like the X is not actually going to the airport. Like
Yeah, because you have to go
you're
down
gonna
too.
fly 10,000 feet
Are you
above the
looking for
airport. If you
distance
take
or
that,
displacement?
if you take that hypotenuse, you actually be at the airport.
That is a fair question. We are going to look at lateral distance.
Oh.
What is lateral distance? What does lateral mean? Sideways. We're going to look at lateral distance here.
Oh, I know.
This way.
Although you could argue that you want to look at both. That you want to look at the descent. But I would argue that it's more useful in this case to look at the lateral distance for an airplane to know how far away they are from the airport. That direction, and then from there they would calculate their descent.
What do you do there?
Wait.
Sarah did something, I don't know.
I honestly
How
like
long is it?
Okay.
Mr. Fossil's circular.
Thank you.
Because I just always imagined the airplane from
I got 40 minutes left.
Yeah, because.
Okay.
Okay, Mr. Costello, you win.
Thank you. I know.
Merc also.
Okay, Saren.
So, I'm a little bit confused.
Surprise.
I don't think gauges work.
We're using air holes.
What?
I don't think gauges work.
No, it works just
It's a
fine.
mirrored image.
No, it's just really weird because like
It's just
it's
mirrored.
I'm imagining that triangle on that side,
It's
right?
mirrored.
Yes.
And then the 10,000 on the
You had the chair do it. The chair happened.
So in gauges, you'd be looking for this.
I like gauges.
Yes, sir.
Kaya.
Go.
So where's the 29? If I'm
Oh my god.
in on your picture,
Yes.
if I just go straight down for that 10,000 feet,
Yeah, watch
Yes.
free fall.
for the hypotenuse, where would the 29 degrees go? On the other triangle. Okay.
Yep. It'd be an angle of elevation looking up toward the plane from that spot. That scenario.
About 40 minutes.
All right. Yes, Bill.
Why can't the plane just go straight now?
Because physics. Cool. All right. So we're gonna. Anyway, voice off. Voice off. All right. So for this picture, what do we know compared to our angle, and what are we looking for? What side do we know? The opposite, adjacent, or hypotenuse? Okay. We know the opposite. What are we looking for? Adjacent. Which of our three trig ratios, so, cot, TOA, sine, cosine, tangent, deals with opposite and adjacent?
TOA.
Tangent, or TOA. So we're going to do tangent of what?
Tangent of
29 degrees. We always use sine, cosine, tangent of an angle is equal to blank over blank.
No.
Done.
Is equal to blank over blank.
You do.
10,000 over X.
10,000 over x. Opposite over adjacent. Is this a very similar setup to our last problem?
Yeah.
Yes. What would we do mathematically from here?
10,000 divided by 2910.
Multiply by x on both sides.
Or that.
X times tangent of 29 degrees is equal to 10,000. Now what?
I'm still writing down.
Okay. Divide by what?
Tangent 29.
Very good. Divide by tangent of 29 degrees on both sides. And we let our calculator do the work. And we figure out x is approximately, let's go to the nearest tenth of a foot as well.
10,040.5.
Nope.
Damn.
18,040.
There we go. 18,040.5.
Isn't that what it's at?
You said 10,000.
I have
I
18,000.
speak
Is that the hypotenuse?
calculators.
No.
Right,
That's why we use tangent.
and what do you think?
29.
29.
29.
Oh, tangent.
Ten.
Those tangents.
Those are high.
Who's on that?
18,040.
So right
Okay.
now, you gotta do 10,000.
Questions?
I like algebra.
And then what do you think?
Good. This is algebra.
Okay,
No,
so
it's in geometry.
No, all of this right here was algebra.
Yeah,
That was algebra.
That's
You know what?
trigonometry.
That was literally algebra.
Algebra doesn't have 3 letters in a row.
That's not true.
Algebra.
I'll show you some algebra 1 problems that have 3 letters in a row.
Algebra.
I will show you 3 algebra 1 problems that have 3 in a row. They're saying algebra 1 problems that have 3 variables in a row.
Yeah, but like,
They're called literal equations.
what are those?
Exactly. They're called literal equations. I cover them in chapter 1.
What's the log?
We didn't do chapter 1.
Is it like-
Okay. Yes. Logarithms happen in algebra 2. Kelly, have you done logs yet?
We're just now starting.
Oh, you'll love those.
It's so
Yeah, you'll love those. Bill,
So that's algebra?
Air war.
this to here was algebra.
Okay, our teachers taught us algebra before they left us.
Oh my goodness.
You had 3 teachers leave in a row.
All right.
Yes.
Yes.
What's LN?
Natural log. All right.
Even your dad left. Wait, no, it's LN, not.
Yeah.
Yes, I know. It's
And he was
natural
wrong.
log.
It's really weird and I hate it, but it's like.
Yes. Okay, voice off, guys. Thank you. Here's a summary. 3 methods to find missing sides. You haven't learned anything about how to find angles yet? We're actually going to learn that next section. 3 methods to find missing sides. If you're given 2 sides, use the Pythagorean theorem. We learned that early on, right? Let's say you're given 1 side and 1 angle. Well, is it a special right triangle? If so, use our special right triangle ratios, our maps. If it's not a special right triangle, we can use our trig ratio like we just learned. So that's a bit of a summary of 3 different ways to find sides based on what you're given. Given 2 sides, Pythagorean theorem. Given 1 side and angle, special right, we'll use the special right shortcuts. If it's not, trig ratio. Questions on that? A little no cap recap for you there.
Yo.
Haha.
Man, I'm